Hardy Weinberg equilibrium is a mathematical way to describe a stable, non-evolving population. And the two scientists who developed this model were Hardy and Weinberg. So what they suggested was that for Hardy Weinberg equilibrium to exist, that is when there is no change in the allele frequency, or the number of times that a certain allele appears in a population. According to Hardy Weinberg equilibrium, 5 things have to occur in order for a population to be non-evolving or at equilibrium. The first is that you need a very large population size. The second is that there's no gene flow. So remember, emigration and immigration. So this population has to be isolated from other populations. There are no mutations that are occurring. Mating is random, so individuals don't choose a mate, they just randomly mate with other organisms, and that there's no natural selection. So if these 5 things were true, then there would be no evolution within a population. So we're going to break down the formula here. The formula is p squared plus 2pq plus q squared equals 1, or p plus q equals 1. So what's important is to break down some of these variables. The p is going to represent the dominant allele, and the q is going to represent the recessive allele. When you see p squared or q squared, that's going to be representing individuals who are homozygous dominant or who are homozygous recessive. The 2pq is representing individuals who are hybrids. And so we're going to break down this mathematical problem with 3 examples. The first question here, if 9% of the population has blue eyes, which is autosomal recessive, what percent is hybrid for the brown eyes? And then what percentage is homozygous for brown eyes? So let's think about this. We're told that blue eyes, or the percentage of the population that has blue eyes, is 9%. Blue eyes is recessive, so are we going to use P or Q? We're going to be using Q. So we're given that the Q squared value, or the number of individuals that are homozygous recessive, is 9%. So we convert that to a decimal and we get 0.09. So you have Q squared equals 0.09. How do you get the Q value? Well, so you just take the square root. So the actual value of Q is 0.3. This is really important because in most problems, you're going to have to solve for Q before you can solve for P. And the reason why is because P represents the dominant allele. So you can have individuals who are homozygous dominant, showing both dominant alleles, or an individual who's hybrid. Remember, if they have that dominant trait, they will also show the dominant phenotype. So both of these have the same phenotypes, but different genotypes. So we have Q here. Coming back up to our equation, P plus Q equals 1. You can figure out what P is by plugging in Q. So we get that P is equal to 0.7. And if we want to know how many individuals or what percentage is hybrid, we just plug in our 2pq, which represents all of the hybrids. So 2 times p times q, and we'll actually come up to about 42%. So 42% of the individuals are hybrids. And then if we want to know how many are homozygous dominant, remember that's going to be our p, so we're trying to find our p squared value. We figured out what our p was, 0.7. Just 0.7 times 0.7, or 0.7 squared, gives you 49%. Sorry about that, guys. The second problem that we have here says determine the percent of the population that is homozygous dominant if the percent of the population that's homozygous recessive is 16%. So here we're given the homozygous recessive. Remember, that's Q. So our Q squared value is 16%, which comes out to 0.16. And to determine our Q, or our frequency, we're just going to convert that by taking the square root, and Q equals 0.4. So what we can do now is figure out what is our P value, because that's what we need in order to figure out what percent is homozygous dominant. P plus Q equals 1, plug in your Q value, and so P will equal 6. Remember, to determine homozygous dominant, you just do P squared. So P squared equals 0.6 squared, or 36%. In our third problem here, determine the percent of the population that is hybrid if the frequency of the recessive trait is 0.5. So here we're not given a Q squared, we're actually given the frequency. So the Q value is 0.5. That's pretty easy to figure out the P value. You just do P plus Q equals 1. So plug it in and you can figure out that P is 0.5. And remember, if we want to figure out how many are hybrid, or the percentage that are hybrid, we're going to use 2PQ. So you just plug in 0.5 and about 50% of the population would be hybrid.